So for homework number 7, problem number 3, the model looks something like this, where we have 6 different ledges, and between each ledge, there's 10 feet of separation. However, between the ground and the first ledge, we do not know that height at all. We do know that jumping from here gives you 0.85 more seconds of drop time than if you had dropped from here. I understand that the 4th floor, that's actually the goal. We'll address that at the very end. For now, let's make a comparison between the 6th floor and the 1st floor. I know that for each of these cases, we have free fall. And I want to complete this formula for both of them. But I prefer to always fill out the formula for the lower height first and then the higher height after. So for the lower height here, the final height is going to be 0 because you hit the ground. And negative 16. So let's pretend that the time for the first floor is t, and it's t squared, plus, and we do not know the initial height, which is this stuff there. So let's just call it h sub I. Now, I want to build the 6th floor, but it's going to be based on the 1st floor. It will be a matter of comparison. Let's fill this out for the 6th floor while at the same time respecting the 1st floor. Here's what I'm saying. I know the final height is 0 equals negative 16. And there's going to be something squared plus something. And you know what? Let me just split this up. Little squiggle. Now, this has to be the time, right? The time for the 6th floor. But how does the 6th floor time compare to the 1st floor? We did say that jumping from here takes more time than jumping from here because this is low and this is really high. Now, the comparison is that jumping from here, there's more flight time, there's more of a drop time. And the word problem said 0.85 seconds. So whatever this time is, this one is that much plus 0.85. For that reason, since this was called t, this would be t plus 0.85. What about the initial height of the 6th floor? How does it compare to the 1st floor? The 1st floor was h sub I, which was this here. But how much higher is the 6th than the 1st? Well, it's an additional 10, 10, 10, 10, 10. So that's 1, 2, 3, 4. That's 50. 50 feet in addition to the initial height, which was h sub I. So for that reason, the initial height from the 6th floor is the original height plus 50 more. This is my setup. This is actually a system of equations. Watch what I do. Let me move this to this side. Let me also move this to that side. And now square means that I can write this piece twice. And now I feel like applying the distributive property. It bled into it a little bit there. Now let's combine like terms here. And now we can apply the distributive property one more time. So I just wrote this down here again. Now watch what I do. The next part is the cool part. You see h sub I, it's here, and it equals that. So by substitution, this can go here. And the reason that is convenient is because, bye-bye, they're gone. And we can subtract this to that side. And then we can divide that into that. So t is about this much time. Yeah, seconds. Now t, recall what t was. T was assigned to be the time for the 1st floor. So the 1st floor has a drop time of this much. So now we can go to our free fall model to find the initial height, which was the 1st floor. Let's do that here. So this was the time for the 1st floor. So I took that time and I plugged it into the free fall model for time there. The final height is 0. I did that, I moved it across. So 31.9 feet, that is the initial height of the 1st floor. But we want the 4th floor. And how high above the first floor is the fourth floor? 10, 20, 30 feet extra. So add 30 feet to that, and your fourth floor height is, what's that, 61.9 feet.